And anywho, that's the story of how I lost my parents for an entire month. Okay, so anywho, what about calculus, guys? I mean, come on, isn't it awesome?
I hate related rates so badly.
They're not that bad, Peter. There's plenty of real-life examples. Now, if only I had a rock to show you one. Oh, hey! Why do you come with me? Alright, so watch what happens when I throw this rock into this pond.
Ooh.
Alright, so related rates aren't really that hard. Let's take the example I just showed you, a pebble being dropped in a pool. Firstly, you're going to try and find the area of the outer ring, or the rate at which that's expanding. Well, you have the radius of the outer ring. That's going to be 4. Oh. You're also going to have the area at which the radius is increasing at a constant rate, which is dr over dt. And that's equal to 1. Now what you're trying to find is dA over dt when r is equal to 4. This is a very basic related rates problem to get you accustomed to the idea of related rates. So firstly, you're going to want to relate area, the unknown, to radius, the known. So that's your basic formula. A is equal to pi r squared. The next step is to derive this function to get dA over dt. You get dA over dt is equal to 2 pi r dr over dt. The last step here is to plug in everything, because the only thing that you don't know is dA over dt. 2 pi, plug in that 4, plug in the 1, and you're left with 8 pi. Simple as that.
Oh, now I get it!
But wait, what about 3D objects?
Calm down, Charlie Brown. I got that on lockdown. Alright, so we just worked with the basic geometric shape, the circle. That's the simplest of related rates. Now we're going to do something a bit more complicated, volume and spheres. So the two most important things you're working with a sphere are V, volume, and R, radius. Let's say for this problem you want to find dr of dt, the rate at which the radius is increasing, when the radius is equal to 2. And let's say the volume is increasing at a rate of dV dt is equal to 4.5. So first, the other thing you want to do is relate the unknown, the radius, or the rate of the radius, to the known, volume. So V is equal to 4 over 3 pi r cubed. Next step is to derive this function so that you can get dr of dt. dV over dt is equal to 4 pi r squared dr of dt. We're left with a bit of a problem here because you're looking for dr dt, but dV dt is what's standing alone. What you have to do here is separate these variables. dr of dt is equal to 1 over 4 pi r squared dV of dt. You do this because you're going to want to divide this section off so that you can get dr dt by itself. Let's plug this stuff in. Alright, so you have dr of dt is equal to 1 over 4 pi parenthesis 2 squared 4.5. 2 squared is 4, so you have dr of dt is equal to 1 over 16 pi times 9 over 2, which equals 9 over 32 pi, which is approximately equal to 0.09. This means that when the radius is 2, the rate of the radius increasing is 0.09, approximately. Nothing more complicated than that.
Now do you get it?
Wait, I just don't get it.
Alright, let's just get to the friends forever moment.
Friends forever!